Kia ora, here's a nice geometry question from Pure 1 back in 2017. So Snehal sent me this one in, and he wanted help with the second half of the question. I'm going to go pretty slowly through the first half though as well. So we're given a semicircle and it's got a centre of O, which is here, and a radius of 6 centimetres. We're told that the radius OC is perpendicular to the diameter AB. So we can see we've got this right angle here. That also means that we know that this length OC is 6. The point D lies on AB, and DC is an arc of a circle with centre B. Okay, so the first thing that hopefully we notice is that to find the arc length DC, which is this one here, we need to figure out what the radius is. So we need to know how long we've got for this length here. Now, that's not immediately obvious, or at least it wasn't to me, but what you can see is that we've got a little isosceles triangle that we can draw in here, because we know that we've got two radii. Where's my pen gone? So draw that in there, 6 and 6. So that means that this angle in here must be 45 degrees, or pi on 4. Now that's good. We're going to need that for S equals R theta in here. The next thing we can say is because this side is 6 and this side is 6, what we've got is a triangle that's similar to a 1, 1, root 2 triangle, only it's a 6, 6, 6 root 2 triangle. And that means that we know that CB, so the straight line CB, is equal to 6 root 2. That's really, really useful because we know that this is the centre of the circle and that DB is one radius and that BC is also a radius. So we're good to find out the arc length DC now, right? Because this length here is 6 root 2 and that's also what this length here must be. So DB, not DC, DB is also equal to 6 root 2. And so S is equal to 6 root 2 times pi on 4, right? This angle in here. So that gives me 3 root 2 on 2 times pi. So that's the first question done. And that's centimetres, so we should put centimetres down there. Now, you could turn that into an approximate value if you wanted to. Just remember to round it to 3 significant figures. I just left it as an exact value, and that's what the mark schedule did. So far, so good. Let's get rid of some of the mess on here and see how we can draw out what we have to do next. Well, we have to find the value of the area of region P divided by the area of region Q. So I just found the area of those two regions separately and then divided one by the other. So the area of region P is going to be area P is equal to the area of the quarter circle minus the area of Q. So we're not going to find that one first, although this quarter circle is very easy to do. So the quarter circle AOC is equal to a quarter times pi times the radius of 6 squared. So that works out to be 9 pi. Now what about the area of Q? There are a couple of ways to do this one. One way to do it is to find, well, let's just go to the way that I did it. I looked at this and I drew my ruler in here. And I could see that I can get the area of that sector pretty easily, right? Because I know that this radius here is 6 root 2, and I know that this angle is pi on 4. So I could do area of that sector and then take away area of the triangle, and that will work fine. And so the examiner's report said that students who'd found 6 root 2 as that radius didn't really have too much trouble with this question. I still think it's a little bit tricky to spot. And the way that I did it is I drew in the other half of the circle, and then I just directly found the area of the segment. So I'm going to try and draw that circle in badly now with my pen. So let's just draw the bottom half of the circle in, and let's extend that line down here. And this is now suddenly quite easy. So let's draw in this down here. So this is also equal to Q. And now we can draw a sector in, and the sector angle here will be pi on 2. That makes this very, very easy to figure out. So the area that we want is going to be half of this whole segment, right? I'm going really slowly here because I think this is quite tricky for some of you. So put it on double speed if you're finding it easy. So we're looking for area Q. So we've got 2 times the area of Q is equal to the area of that whole segment. The area of a segment is half r squared theta minus sine theta. And in this case, we're working with the radius, which is 6 root 2 squared, and the angle is pi on 2, and sine of pi on 2 is 1. So that gives me 2q is equal to a half times 36 times 2 times pi on 2 take away 1. So 2q is equal to 18 pi minus 36. So q is equal to 9 pi, take away 18. So that's good. And now we're going to work out what P is equal to. So area P is equal to 9 pi from the quarter circle, take away 9 pi minus 18, which leaves me with simply 18, and the area is centimetres squared. So the ratio that we have to find is P over Q. It's going to be 18 over 9 pi minus 18. And that doesn't turn out to be, there's no way to do an exact value with that beyond that, so I'd give that a full mark. But if you want to round it, you get about 10.274 there in your denominator, which works out to be 1.75, blah, blah, blah. So to 3 significant figures, I got 1.75. And that's a ratio, so that doesn't have any units. Okay, so Snehal, I hope that helps. The other way that you could do this question, as I said before, is just to find the area of the sector. I'm just going to show you guys this before I do another video. So the other way to do it is to find this sector in here, which is very easy because we know that radius. And then you can just find the area of that triangle. And you can do that using half the base times the height, or the other triangle formula. Cool. Thanks for watching. Send in any more questions you've got today.